Hello everyone. In this video I'm going to be looking at how to solve radical equations. So your basic radical equation, as you see here, I have of course a radical on one side and I have a number on the other. Now the basic strategy in solving rational equations is to isolate the radical on one side, whatever the root happens to be, and then raise each side to that power, and then solve for x, or whatever the variable happens to be. So in this case, already been done for me. My radical is isolated on one side, and in this case it's a square root. So what I want to do is raise both sides to the second power because the index of my radical is 2. Now if you remember square roots, we don't usually have the index written, so we assume that if there is not an index written, that it's a square root. That's how I know it's a 2. So I will raise both sides to the second power. Squaring a square root cancels it out, which means I'm left with what's underneath, which is my 3x plus 4. On the other side, I have a 36. Now that my radical is gone, I want to solve for x as I normally would. So I will subtract 4. Now I have 3x equals 32. Continuing to solve, and I will have divide by 3. So my answer is x is equal to 32 thirds. Now the thing we have to be careful of with solving radical equations is when you square answers, or when you raise both sides to a power, sometimes it can create what's called extraneous solutions. And that basically means that it creates an extra solution that is actually not going to work. That with the new equation that's created, it works, but in the context of the old equation, it does not. So basically, the way to make sure all of our answers are not extraneous is we take our answer and substitute it back into the original equation. So in this case, I'll say 3 times 32 thirds plus 4 inside my radical. My 3's will cancel out. I'm left with 32 plus 4. So the square root of 36 equals 6, and that was my original equation, so it checks out. So we've confirmed that our answer is 32 thirds. Let's see another example. In this case, I'm still solving for the variable, and I'm going to do so by isolating my radical. In this case, I have my radical and a 3 on one side of the equation. Again, I want just my radical, so I'm going to move the 3, which means I will subtract it from both sides. Now I have the square root of 5x minus 6 equals 5. Now I'm going to raise both sides to the second power since it is a square root. It's going to cancel out my radical, and I'll have 5x minus 6 equals 25. And I will continue to solve for x by adding 6. Now I have 5x equals 31. And lastly, by dividing by 5, I'll have x is equal to 31 fifths. Now, as I mentioned before, since I want to make sure I do not have an extraneous solution, I'll take my answer and put it back into the original equation. So I'll have start out with the square root of 5 times 31 fifths minus 6 plus 3. My 5's cancel, and I'm left with 31 minus 6. 31 minus 6 becomes 25. So the square root of 25 is 5 and 5 plus 3 does equal 8, which is what I want, so it checks out. So this is how we approach solving radical equations. Isolate your radical on one side, raise both sides to the appropriate power, and then of course check your answer.